Okay, so welcome back. And now what I'm going to do is I'm going to show you how to graph this function. I'm going to do a little bit differently. I'm going to walk you through my thought process because there's a lot of different things you can do, and you can find videos that will show you how to graph this differently. If you read a textbook, one textbook will show you differently how to graph these things. I've seen where people will graph the sine curve and they'll graph this along the x-axis, right? So using the Cartesian plane, and they'll graph it and then they'll translate it to what's going on here. I'm not going to do that, but I'm going to walk you through my thought process, and I hope that it will better help you, give you some tools to approach these. Now I'm going to use the same steps that I've been using, but I'm going to approach it a little bit differently to give, again, the idea of finding out what this looks like. Again, we should know that this is a rose curve, right? So we should have a general idea of what this might look like, which is going to be very helpful. Okay, when you know the form of the equation, and you know, hey, this is the form of a cardioid, or a lemniscate, or a limacon, or a Archimedes spiral that we're going to talk about next. It'll give you an idea of what it already looks like, and that will also help you approach this the right way, okay? So, with no further ado, let's jump right in. So the first thing I want to do is, again, symmetry, right? This is sine, right? So automatically I know this is going to be symmetric with respect to theta equal to pi over 2, okay? But test the symmetries anyway, right? Test, again, practice test doing the tests for symmetry, whether it's, testing this, whether it's symmetric with respect to the polar axis, the pole, or theta equal to pi over 2, okay? So that's the first thing you always want to look at, symmetry. Understand the symmetry of what's going on, okay? Also, in this case, since we're dealing with a rose curve, look at the n value. N is 5. It's odd, which means we're going to have n petals. So in this case, 5 petals. We're going to have 5 petals, which is an odd number, and it's going to be symmetric with respect to theta equal to pi over 2, right? Which is the y-axis, okay? Which means one of the petals has to be on the y-axis, okay? And then it's going to be flipped, half on this side, half on the other side. If one of the petals is not on the y-axis, then it'll never be symmetric. You will never be able to get it to be symmetric across that line. So again, this is kind of my thought process of basically critical thinking, right? I'm figuring out, okay, based on what I'm given, how is this thing going to look? Okay, so I know one of the petals has to be either on this here or down here. Okay, won't be both because it's odd. Okay, so there's my thought process. Okay, good. So let's go from there. Okay, so now that we've got a general idea of what's going on with symmetry and with the petals, now let's look at the zeros. Where do the zeros happen? Where does the radius equal 0? Which means, where does it cross the pole? Right? Or intersect the pole, I should say. So now, well, I'm going to set this equal to 0. 2 sine 5 theta equals to 0. Now, I've seen other videos and other people solve this differently, and that's fine. I'm going to solve it the way I think is more instructive, or just as instructive. So here's my thought process. Okay, so I've got this, right? I want it equal to 0. I want to know all of the values of theta that make r 0. Now, if I divide this by 2, I'm just going to get the simplified equation of sine of 5 theta equal to 0. Now, I know sine of any angle is equal to 0 if that angle is what? Is equal to pi 0, right? 0 or some adding or subtracting some multiple of pi. So that means that 5 theta, right? 5 theta is the angle inside the sine function. So that means 5 theta has to equal either 0 or plus or minus some multiple of pi, where k is an integer. So now what I'm going to do is now I want to divide everything by 5. That means theta, okay, so that's the angle I'm interested in, right? That's the angle that I'm going to be graphing. That means theta is going to be equal to 0 plus or minus any multiple of pi over 5. Okay, so that means I'm going to cross the pole at 0, right? So let's write this down. So 0, pi over 5, 2 pi over 5, 3 pi over 5, right? And 4 pi over 5, right? Okay, so now that we've got that, and in fact, I'm gonna write that over here just to keep this out of the way. So we know that zeros, right? So if we're talking about the zeros, we know that that's going to happen when theta is equal to 0 plus or minus a multiple of pi over 5. Okay, now let's talk about, let's talk about the maximum values. Okay, so now, where are the maximum values located, the maximum value of R? So this is going to be the tips of the pedals, right? So the maximum value of radius is going to happen at the tips of the pedals. So I want to know where those are located too. Okay, so let's figure that out. So that means we want to maximize R. Well, R in this case will be maximized when sine is maximized. Sine is maximized at 1. That's the maximum value, right? The range of sine is 1. So that tells me what I need to do is I need to first find where this is equal to 1. So sine 5 theta equals 1. Okay, so now sine equals 1 in general when the angle is pi over 2, right? Or adding or subtracting some multiple of 2 pi. Okay? Or it could be negative 1, right? We can find out where it's negative 1, where it means that this is going to have a negative, maximum negative radius. Okay? So let's think about that. So let's do 1. So maximum value of 1 is going to happen when what? 5 theta is equal to pi over 2 plus or minus some multiple of 2 pi. Which means theta is going to be equal to what? Pi over 10 plus or minus pi over, 2 pi over 5. Okay, so that means what? We're going to have a maximum value at 2. So we're going to have 2, so the pedal will be 2 at what value? Well, it'll be at pi over 10. It'll be at 5 pi over 10, which is pi over 2. It'll also have a maximum value at what? Let's see, 9 pi over 10. It'll also have a maximum value, well, let's see here, 1 plus 4 is 5, 9, 13. 13 pi over 10. And then it's going to have another one, the last one is going to be at what? It's going to be at 17 pi over 10. So those are going to be where the angles, where the radius is going to be 2. Notice how pi over 2 is right there. So we know, just like I was saying, one of the petals is going to be on the one of the axis. Right there, pi over 2, it's going to be 2. Because if this is 1, right, so this is where it's 1. When this is 1, the radius is going to be 2. So guess what? We know we have, oh, let me get a different color. Okay, so we know we have 1 point right there. Okay. And we also know that the other points are at these angles, where it's also going to be 2. So we got to figure out where these angles are. Okay, so those are where the maximum values are located. And we know we've got zeros at these angles here. Okay. So again, let's put it over here. So maximum. So I'll put max of R is going to be happens when theta is equal to pi over 10 plus or minus 2 pi over 5. Okay. Oh, this should be K. Okay, so now, another thing, I'm going to stop and I'm going to explain something else. Another thought process that I go through is like, okay, if I know I have 5 petals, then I know that those 5 petals are going to be equally divided around the unit circle. Okay? And so it makes sense because if I divide 2 pi, I have 5, right? If I divide 2 pi by 5, that's going to tell me where each petal, what sector, right? What sector of the unit circle each petal lies in. And so it's not a coincidence that you get 2 pi over 5. Because, look at this. We have a maximum value at this angle plus or minus 2 pi over 5. Because if I take 5 times this, I get 2 pi, which is 1 revolution. So that's why if you look at starting at pi over 10, and if I add 5 pi, if I add 2 pi over 5 times, guess what? The very next one is going to bring me back to here, because that will give me 21 pi over 10, which gives me 1 revolution back to pi over 10. Okay, so these are the angles where I'm going to find those petals. Okay, so again, this should make sense, right? Also, again, the 2 pi over 5 tells me how I'm going to divide this up. Now, these lines that I drew on here, I drew these lines on purpose. These are the 30 degree and 60 degree increments, and the 30 degree increments and the 45 degree increments. So this would be what? This would be pi over 6. This would be pi over 4. This is going to be 2 pi over 6 or pi over 3, right? This is going to be pi over 2. And then it keeps going, right? So this is, excuse me. So this is going to be 1, 2, 3 pi over 4. right? This is going to be 3, 4, 5 pi over 4 is this one right here, 5 pi over 4. Okay, so let me erase this, what I got going on here. Okay, so let me write this over here. So this is going to be 5 pi over 4. Now again, you might not be able to see this on the camera, but again, I'm saying it so as I write it, so you make sure you write it down if you're taking notes. And so this is 5, let's see, 3, 4, 5, 6, 7 pi over 4 is this one. Okay, those are all the 45-degree angles. And then if I do the 30-degree angles, then this is pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, which is pi over 4, 4 pi over 6, which is 2 pi over 3, 5 pi over 6, which is this one right here. And then, of course, this is going to be 2 pi, this is going to be pi, right? 6 pi over 6, which is pi. And then we got 7 pi over 6, 8 pi over 6, or 4 pi over 3. Okay? And then we've got 3 pi over 2 right here. Nine pi over 6, oops, or oh, hold on a second. Hold on, this is 5 pi. So 10, 5 pi over 3. And this is 11 pi, oops. Pi over 6. And then of course, 0 or 2 pi. Okay, so the reason why I did is just so it's going to make it easier for me to sketch, and I want you to see these angles. Okay, so now I'm going to do the table of values. Okay. Okay, so let's do the table of values. So I'm going to start way over here. Okay, so I don't know how much of this I'll fill out. Okay, so let's start with 0. Okay, so we got let's see here. What do I want to do? Okay, so let's just do 0. We'll do pi over 6. So we'll just work our way around. So pi over 4, pi over 3, pi over 2, okay, and then we got 2 pi over 3, over 4, 5 pi over 6, pi, 7 pi over 6, 5 pi over 4, 4 pi over 3, yeah, and then we've got 3 pi over 2, 5 pi over 3, 7 pi over 4, 11 pi over 6, and then we got 2 pi. Okay, so let's do this. So now, notice that this is going to be 0 at multiples of pi over 2, 0 and multiples of pi over 5, rather. Okay, so 0, it's going to be 0. Okay, so now, so at 5 pi over 5, so 5 pi over 5, so at pi it's going to be 0, right? That makes sense. So pi it's going to be 0. And at 2 pi it's going to be 0. Okay, as far as what we have on our table. And then the maximum values of r, which is 2, is going to happen at pi over 10, and then adding or subtracting 2 pi over 5. So one of the ones we found was at pi over 2, right? So at pi over 2, it has a radius of 2. What other ones? Well, we have pi over 10. Let's see. So we have pi over 10, pi over 2, 9 pi over 10. So all the other ones are odd ones that are not going to show up on here. Okay. So let's fill in the rest of the table and see what we get. Okay? So here's what we have. So at pi over 6, it's 1. So pi over 6, if you stick pi over 6 here, you get 5 pi over 6, which is going to be right here. And the sine of a 30-degree angle is 1/2, which gives you 1. Okay, and it's positive. Okay, so pi over 4. Well, let's do pi over 3. So we get negative 1.73. So pi over 3, which is 60 degrees, which gives us 5 pi over 3. Okay, so 5 pi over 3 is where? Where does this angle end up with? 5 pi over 3 is right here. Okay, and sine is negative. So this is going to give us a negative what? It's a negative 60 degrees, right? 60 degree reference angle. So that's going to give us square root of 3 over 2, which is going to cancel with this 2 here. So we get the negative square root of 3. Okay, which is going to be approximately negative 1.73. Okay, so what else? Now we have 2, and then here we get 2 pi over 3. Well, 2 pi over 3, which is going to equal 10 pi over 3, and 10 pi over 3 is the equivalent to what? Right? Well, just think about it. So 10 pi over 3 is the same as 2 pi plus what? Well, 2 pi is what? 6 pi over 3, which leaves 4 pi over 3, which is right here. So that gives us another negative square root of 3 because again, the reference triangle is going to give us square root of 3 over 2, and which is going to cancel with this 2, which is going to leave us negative square root of 3. So this is also going to be approximately negative 1.73. Okay. Now 5 pi over 6. Okay. So 5 pi over 6, what does that do? 5 pi, that's going to give us 25 pi over 6. So again, 25 pi over 6 is going to equal what? Well, how many revolutions is that? Well, 12. So that gives us 4 pi, right? 4 pi, which in this case is 24 pi over 6. So that gives us plus pi over 6, right? Because 24 pi over 6 is 4 pi, which is 2 revolutions around. So we end up with pi over 6. And so again, that's going to be the same as this one. So that's going to repeat. So this is going to be 1. Okay? And so 7 pi over 6, again, you're going to multiply by 5. That's going to give you 35 pi over 6. And again, 35 pi over 6 is going to give you what? 24 pi over 6 plus what? Yeah, 35 pi over 6. If I have 24 pi over 6, which gives me what? 11 pi over 6, which is right here, which is going to be negative. And so that gives me negative sine of 30 degrees. That's a negative, so that's sine of negative 30 degrees. Okay? Sine of 30 degrees is 1/2. But it's negative 1/2, so that gives me a negative 1. So this gives me a negative 1. Okay, now, what about this one? So we're going to get some others. So here's another one. Did I miss one? So here's another one, 11 pi over 6, right? So this can be 55 pi over 6. So if I start with 55 pi over 6, so 55 pi over 6, well, now what I can do is, that's going to give me what? 48. 48 pi over 6. So that gives me 8 pi, which is a multiple of 2 pi, right? So that leaves me with what? With 48, that leaves me with 7 pi over 6 again. So now I'm back to 7 pi over 6, which is right here, which gives me a negative 1. So this also gives me a negative 1. And so I can continue doing the same thing with pi over 3 too. Let's finish the rest of this. Then we'll go to the 45-degree angles, pi over 4. Okay, so we've got this one. So 4 pi over 3 would equal 20 pi over 3. So 20 pi over 3 is equal to what? Well, how many 3's go in the 20? Well, it's 6. Right? So 6 pi, right, or 18 pi over 3 plus what? 2 pi over 3. This is equal to 6 pi, which is a multiple of 3 revolutions, right? That's basically 3 revolutions. So I end up on 2 pi over 3. Well, 2 pi over 3 is right here. So that's going to be positive. It's a positive 60, it's 60 degrees. And so that's going to give me a positive square root of 3. And of course, this will also give me a positive square root of 3, I bet. Okay, looking at the pattern. So, but let's try it. 5 times 5 is 25, so that's going to give me 25 pi over 3. Okay. Is that right? I just want to make sure. So 25 pi over 3, 25 pi over 3. And if I have 18, so I can actually have what? This is going to be 24. So 24 pi over 3 gives me 8 pi, right? So that's a multiple of 2 pi, and then I'm going to have a pi over 3 left over. Pi over 3 is in the first quadrant, so that's going to be positive, and it's again square root of 3. So I was right. And then what about 3 pi over 2? Well, that's going to be 15 pi over 2. Well, 15 pi over 2 is 1, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? So it's going to be this angle right here, 3 pi over 2. Well, it's a maximum here, which means when it goes to here, it goes to negative, right? Yeah, so it's going to go 3 pi over 2, right? The sine of 3 pi over 2 is negative 1, so it's negative 2. So I end up back on here. Okay, because it's going to be negative 2, so I'm going to be facing this way, so it's this way, but negative 2 means I'm going to flip it 180 degrees, so I end up back on that dot. Okay. So this is going to be negative 2. Where's it at? This is going to be negative 2. Now the 45-degree angles. Well, if I put in pi over 4, this is going to be 5 pi over 4. Where's 5 pi over 4? 5 pi over 4 is right here. So this is going to be the sine of this, which is negative square root of 2 over 2. So this is going to be negative square root of 2 over 2. Okay. And then 3 pi over 4, that's going to give me 15 pi over 4. Okay. So 15 pi over 4, let's go through this. So 15 pi over 4 is equal to what? Well, I can get 8 out of there. I can't get 16, so it's going to be 8 pi over 4, which will give me 2 pi, which is 1 revolution, plus, well, what's left over? 7 pi over 4. Well, where's 7 pi over 4? Right here. So this is also negative, so this will be negative square root of 2 over 2. Right here. So negative square root of 2 over 2. Now, at this point, you should be able to see the pattern, right? So 0, 1, negative, negative, positive 2, negative, negative 1, 0. Now it's going to go negative 1. So guess what? Positive, I bet you this is going to be positive square root of 2 over 2. And then positive 3. And then it's going to be negative 2, positive 3, and then positive square root of 2 over 2. So I can fill the rest of it. Now I've got it all filled out. Now, okay, let's graph these points. Okay, we got 0, 0, so we've got 0, 0. We're going to have a 0 there. Okay. Pi over 6 is 1. So pi over 6, it's going to be 1. Now, let me find the approximate value of square root of 2 over 2. Okay, so hold on. Okay, so is this, hold on a second, is this degrees? Oh, hold on a second, hold on a second, hold on a second. Okay, so this is just square root of 2. Yeah, I forgot, the 2 cancels with this one, so I got a little ahead of myself. So these 2's are not here. These 2's are not here. Okay. Okay. Okay, that's good. So now if I do the square root. Okay, so 1.41. Yeah, that makes sense. So 1.41, so 1.41, 1.7. Okay, so let's look at this. So this is going to be approximately negative 1.41. This is approximately negative 1.73. Okay, so again, if I just keep that in mind, so this is going to be so pi over 4. So pi over 4 it's going to be negative 1.41. So it's going to be negative 1.41, which is going to be right about here, let's say. And then at pi over 3, which is here, it's going to be negative 1.73. So it's going to be right about here. Negative 1.73. Let's say that's about right here. And then at pi over 2, it's 2. And then at 2 pi over 3, it's going to be negative 1.73 again. So 2.3, so it's going to be over here. So it's going to be negative 1.73, which is going to put it down here. So again, right about, let's say right about there. And then at 3 pi over 4, it's going to negative here, so negative 1.41, which is going to be over here. So negative 1.41, which would be, let's say, about right there. Yeah, looks good. And then at 5 pi over 6, it's positive 1. So at 5 pi over 6, it's going to be right here. And at pi, it's 0. And then 7 pi over 6, it's negative 1. So at 7 pi over 6, it's negative 1, which means it's going to be here again. So it's back on here. And then at 5 pi over 4, it's positive 1.41. Right there. So it's back on that dot. And at 4 pi over 3, it's positive 1.71, so it's back on that dot. And then at 3 pi over 4, it's negative 2, which is, again, back on that dot. And so it's repeating now. So here, it's here, and then here, it's here. And then at 11 pi over 6, it's at negative 1, which is back over here. And so it's repeating now. Okay. So, last thing I want to sketch, and I know I'm taking a long time, but I want you guys to see this, is where are the maximum values? We got this one, but where are the other maximum values, which are going to be at pi over 10? Okay, so what is pi over 10? What degree? I'd like to know the degrees, right? So pi over 10, and we want to do the conversion of 180 degrees over pi, right? So 180 degrees for every pi radians. So if we multiply this by that conversion factor, we get 180 divided by 2, which is 18 degrees. Okay, so where's 18 degrees at? Well, every 18 degrees, this is 90 degrees, right? Right, so 18 degrees. So again, just to give myself something to think about. 18 degrees plus or minus. So in this case, if we change this to degrees, what are we adding? Well, that would be 180 over pi, so that'd be 360 divided by 5, right? Because you're taking a whole revolution divided by 5, right? That goes back to what I was thinking before. So what's 36 divided by 5, or 360 divided by 5 is 360 divided by 5 is 72, right? Yeah, 360 divided by 10 is 36 degrees, double that, 72 degrees, right? Plus or minus 72 degrees, right? And that makes sense because the first one is 18 degrees and the next one is at 90 degrees. So, and this is 30 degrees, right? So I would imagine, again, if I'm estimating, right? So this is 30 degrees. So 18 degrees is what? 18 degrees would be maybe somewhere about, so this would be 15 degrees. So let's say 15, so that would be 15. So maybe it's right about here. And the next one is 72 degrees, 90. Oh, well, guess what? It's symmetric with respect to the x-axis, so I bet you the next one is going to be about right here. Ah, excellent. So then this is 18 degrees, right? So if I do 72 degrees from here, because this is going to be 18 degrees here, which then it'd be what? 18, 54 degrees from here. 54 degrees from here is going to be what? It's going to be about here, right? This is 60. This is 45. So this is 15 degrees right here. So 45, so this is 60. So that's 6 degrees. So I would say it's going to be right about here. Right? So 45 to 55. Yeah, so it's going to be about 2/3 of the way. So I'd say it's about right here, which means then this one is going to be right about here. And now, we can go ahead and sketch this. Okay, so because here is the maximum point right here. So we know it's going to go, and it's before this one, so it's going to go something like this. Right? And then it goes negative. So it starts here, goes here. So right, so it starts here. Well, let's see. So 0, and then 1. Yeah, so before 30 degrees, it's going 0, and then it's going to 2, right? It's going to 0, then 2, and then it goes down to 1, and then it goes negative. So it's going like this, and then it's going this, negative, negative 2. So it's going to do something like this. And then it's going to keep going, and it's going to do and it's going to keep going. Oops. Like that. And there's the graph. Okay, so I know this is a longer than usual video, but I thought it was important to go through my thought process and how to attack this thing and understand the thinking behind as I'm going through this. Now, did you have to plot as many points? No, but I wanted to plot as many points as possible so you guys can see. Now, again, if I were you, I would do the same thing. I would go through this process, again, especially for practice on an exam situation, right? So this is where you do your practice on the board, at home, when you're doing your homework, okay? Do whatever needs to be done so you understand what's going on, because then what happens is in the exam, you don't have to do all of this stuff. You'll have an idea and you can do part of this stuff, but then enough just to get the idea of what's going on, and then you can sketch the graph knowing how this thing behaves. So remember, use the maximum values, find the zeros, use the symmetry, find the pattern, right? You know, how many petals there are, okay? Is it even or odd, right? If n is even, then you've got double the number of petals, right? And then you know you have symmetry everywhere, because if it's double the petals, then you've got other things going on possibly, okay? But again, use your table to help you as well. Okay, have a great day. Take care.